All right. As I mentioned earlier, this one is not going to be overly difficult for you because of in geometry we talked about a lot of this stuff, whether you had it previously or you're in it this year, we've talked about it. Inverse relationship means you have to look at its inverse. We're going to use inverses a lot of times if we want to get the angle by itself. Right now we have A equals sine of theta. The angle is not by itself. And you can normally look at the calculator if you've kind of forgotten what they are. And if you look on the calculator, obviously the opposite or the inverse of sine is, if you look right over here, the inverse of sine is arc sine, okay? The inverse of cosine is arc cosine, or cosine to the negative 1. And the inverse of tangent is tangent to the negative 1, or arc tangent. Okay? So those are very helpful if you need to look there, if perhaps you forgot what they are. So this first one, all I have to do is get sine out of there, and I'm going to get it out of there by taking the inverse. So I'm going to take the arc sine of A, and over here it's really going to be, well, I better not write it that way. I'll write it both ways for you, and then you can decide which way you want to write it. That's really what you're doing in this problem. Do you agree I took arc sine of both sides of the equation? On the right side, the arc sine and sine are inverses of each other, so they do cancel. So basically sine to the negative 1 of A equals theta. Theta is now by itself. That is one way you can write it, but the book may write it a slightly different way, and so I'm going to show you that just so that it's not foreign to you if they do that. What they can do is actually go like this. They actually write arc sine of A equals, and I didn't leave enough room, so we'll write it somewhere else. Up here. Arc sine of A equals arc sine of theta. Do arc sine and sine still cancel, though? Yeah, there's nothing different. It's just I'm showing you another way they could write it. And so then you just go like this. So theta equals the arc sine of A. So you can either write it the way that we have it in green up there or the way we have it in red down at the bottom. They both work the same way. I'm normally kind of going towards this one because it's quicker to write, is the only reason. But now if you see that arc sine written out, you know what it means. It means pretty much the same thing. And I look at it as saying find the angle, so it wants to know where is this going to happen. That's kind of how I look at arc sine or arc cosine, where it wants the angle. Okay? So here's where the unit circle may prove helpful. It says determine the value or values, again that's what the parentheses means, of x if the interval is 0 to 360. Based on this interval that we have right here, should I include 0 and 360 or not? Yes, how do you know that? Because the equal to is on there, right? So I have to find answers from 0 to 360 that actually make this true. Now, the reason I had you stop, because remember, on the unit circle, aren't some of these going to happen a whole lot of times? And you could keep going around that unit circle 17 times if you feel like it. So I just narrowed it down so that we don't have to find it all. So this, I'm kind of saying, that's the angle right there, and here's arc sine of 0. So I look at that as saying, where is sine 0? Because it's actually, it's asking you for the angle. Any places that sine is 0? Anybody got one? Yes. Are you sure? So right here, you're saying that sine is 0? Well, what's your period? It's 0. Now, should I write 0? Yeah, 0 degrees is one of them. Okay. You could write 0 radians if you feel that way, but seeing the interval is 360, you probably stick with that. Yes. 180, I've been told. Well, let's find out. What's the order pair there again? It's negative 1 comma 0. So is sine 0? Yep. And is there anything else? Yep. That's a great question. I'm going to come back to that one in a second. Yes. The question I was going to come back to is, it was asked if could you put positive and negative 180 degrees? Is negative 180 degrees technically correct? Yes, but is it in that interval? No, so that's why I would not write that. I see exactly what you're thinking. Many of you are thinking back to that 180K, 360K, and things like that. But this is, I narrowed it down for you. I only want those answers between 0 and... Now, could I change that interval from problem to problem? Yeah, I could say give it to me from negative 180 to 180, and then your answers might change a little bit. Or I could just say tell me from 0 to 90. Okay, so watch out for that. So this one's asking, again, where is tangent going to equal 1? Again, from 0 to 360, does anybody believe they know one place that tangent will be 1? Yes. 45 degrees is correct. Very good, because it is square root of 2 over 2. Square root of 2 over 2. And remember, tangent is sine over cosine. And if I take sine over cosine, is it going to be a positive 1? Yes, it is, and that is 45 degrees. Very good. And 45 degrees happens to be in the interval. Now, it does say value or values, so it's possible there's only one. Is there another one? Yes, Jenna. 225, what quadrant is that one going to be in? In third, so is that true? It's going to be right there. Is that going to be a positive 1? Most definitely, and that is what you said, 225? Okay, anything else? Well, how about these other ones? Here and here. Oh, tangent's negative 1 there. Very good. Why don't you try letter C right now on your own? That's basically asking, whenever you see the arc on there, it's asking where is cosine square root of 3. That's asking where. So give me the angle. I'm guessing that was probably enough time. So it's asking where is cosine square root of 3. So it gets a little bit more complicated. Yeah, that's a pretty good one. All right, square root of 3 over 2, where are we looking? Yep. Is 30 degrees, is that correct? Let's find out. Order pair there is square root of 3 over 2 comma 1/2, agreed? So is the cosine value there actually square root of 3 over 2? Yep, because cosine is the x value, so 30 degrees. And does it make sense that cosine's positive in the first quadrant? Yeah. Any other ones? Yeah. Are you sure? Where's that one? What quadrant is that on? Right there. Thank you. That's very descriptive. Right there? Yeah. Oh, okay. So is this square root of 3 over 2 and negative 1/2? So is that right? Yeah, so 330. Are there any others? Well, how about over here? Oh, it's negative. How about over here? Yeah, again, cosine's the x value, so do those two over here make sense to be negative? Yes, these two over here make sense to be positive. So there you go. Now, if we went back to earlier in this chapter when I said to give me all of them, that's when you'd have to start bringing k back in there and do that. But right now, I just narrowed it down. But make sure when you're done, all your answers fit in that interval, because I'm pretty sure I do change the interval, or it gets changed on you. It says maybe negative 180 to 180, so you got to kind of look at things a little differently. Okay? So keep that in mind. There's a lot of ideas you could look at for this one. Letter A was not meant to be a trick question. This question right here is basically asking where is sine 0.4212? And then it's asking for sine at that location. Do you see what I'm saying there? So don't sine and arcsine still cancel? They cancel each other no matter what order they come in. Because again, it's first asking me where, and then it's asking me what sine is there. Well, it better be 0.4212. Do we know exactly where that is? No. Is that something we could figure out on the calculator? Yeah, if we wanted to, but we don't know where that actually happens, so that is your answer. So that was just me showing you that arcsine and sine, and any of those can be in either order. They still cancel. Again, here is the arc in this one, correct? So it's asking where is sine 5/13. It does tell us assume all angles are in quadrant 1. Do you suppose I could change that as the assignment goes on? Oh yeah, watch for that. So is 5/13, is that one of them on your unit circle? No. But if we know it's in the first quadrant, well, you should probably know what I'm going to tell you to do. Draw something in the first quadrant, and you always connect it to the x-axis. Now, what do you want the angle to be? Theta, x? It doesn't really matter to me. Theta? Once again, I'm really doing bad on the thetas, but that's all right. So if sine is 5/13, does it matter where I put the 5 and the 13? Just put it wherever? So where's the 5 got to go? It's got to go, see, opposite, right? So remember, so Katoa. And we have to draw a picture because this isn't on the unit circle. Well, it is, but it's not one of them we know. So opposite is 5. Where's the 13 go then? Hypotenuse. Anybody know that triple? 12. Now, is it a positive 12 or a negative 12? Why is it positive? Yeah, you're going to the right. Very good. And so do you agree that this picture describes that portion? That shows me where it is. That shows me theta. That's where this would happen. Because I don't have the unit circle to just find it for me. So what it's asking me for at that place is to find tangent. Is that something we can figure out by looking at the picture that describes where that happens? Yeah, we just did it here. It's opposite over adjacent. So if here's theta, opposite is 5, adjacent 12. There you go. So did these two in letter B cancel like they did in the first one? No. But one of them kind of showed me where, and then the other one asked me for something there. at that particular location, because it's not arctangent. Okay, it's not arctangent, it's just sine, arcsine. Okay. How about this one? Letter C. Is that one that we might know where that is? Do we know where cosine is 1/2? Yeah, we know where cosine's 1/2 in the first quadrant. And you can draw, if you don't know, is it okay to draw it? Yeah, if you forget, just go ahead and draw it. It doesn't matter. Here's theta. If you forget, it'd be what? 1, 2, right? Should be no surprise that, yeah, the other one, but square root of 3. Should have figured that one. So you can either do the picture or not, or you could go here and say, well, cosine is 1/2 where? By doing this one. Where's cosine 1/2? I think some of you already told me. There's 2 ways to do this one. And I'll show you both. So do you agree that is where cosine would be 1/2, is right there at 60 degrees? And so it's asking for secant there. Well, if cosine is 1/2, secant is 1 over cosine, which means take the cosine answer and flip it. 2, there you go. Could you figure that out from this picture? Yeah, find cosine, it's 1/2. Secant of that is just the flip, it's 2 over 1. You could figure it out either way. This one just happened to be on the unit circle, so you had 2 methods. And why wasn't this one we could do that with? Because it's not one we know on the unit circle. It's not one of them that we could say 60 degrees or 30 degrees. Whoa, too far. Whoop, too far. This one's an interesting one. That's asking where is secant 2? So it's asking where is secant 2 over 1, right? That's what it's meaning? So it's very good. This question is asking where is secant 2. Another way of saying it is where is cosine 1/2. Excellent. It's the exact same question. Okay, where is cosine 1/2? Where is secant 2? Well, didn't we just kind of do that one over here? All right. So where is cosine 1/2? Well, there it is right there, right here. And what's sine there? Well, square root of 3 over 2. Could you have figured that one out from this picture? Yeah, because here's your angle. And again, it does say quadrant 1. That's pretty important, okay? And sine is opposite over hypotenuse. Hey, it's square root of 3 over 2 either way. So are some of these, yeah, you're going to be able to do it right on the unit circle, no big deal. And then some of these, you're going to have to draw a picture for. And I think you'll notice right away. But the nice thing is I do think they keep the numbers pretty nice when they do them this way. They give you triples most times if they're that way, so you don't have to sit there and figure them out. So basically, I look at it this way. Any of these arcs are asking, where does it happen? Okay? And just to make sure you get it, I'll ask you just one last question. It's very simple, though. Better do it fast, though. Arc cotangent. I don't know what I want to write there. Let me just put the X. Nope, that's not what I want to do. We're just going to stop, and I'll ask the question separately.